Okay, today's lesson is going to take us about 25 minutes. If you got questions, make sure you pause me. But we're going to use these formulas that we started out using yesterday. And yesterday we did the first problem. Could have gotten done the second one, but I forgot that we had more time yesterday than what we did. So here we go. $1,500 invested in interest rate 8% per year, compounded semi-annually. Find the value of investment after 5, 10, and 15 years. So yesterday we solved an exponential equation. We also plugged some values in. Today you're going to get used to using this formula. And the formula is what is listed above. A, or the amount after t years, is equal to P. P stands for principal. When you're dealing with money invested, do you know what principal means? The amount you start off with. So the amount you start off with is P times 1 plus the rate divided by the number of times it's compounded during the year raised to the NT, where T is the number of years that it's invested for. So that's our formula, okay? And so now we just got to fill in the blanks. We don't know the amount. That's what we're going to try to find. But we do know the principal. What's the principal in this problem? $1,500 times 1 plus, what is the current rate? 0.08. Divided by? It's compounded semi-annually. How many times a year is it compounded? Twice. So we divide it by 2 and we raise it then to the 2t power. We can simplify this. What's 0.08 divided by 2? So we have 1.04 raised to the 2t. So the whole idea is that I know you can plug in the numbers, that's not that difficult, but can you write the equation? That might be a little bit tougher. And so there you go, there's your formula. So let's just go to our calculator and let's type it in. I'm going to go into y equals, and I'll type in 1,500 times 1.04 raised to the parentheses 2t. And if I go to my table, that way I can generate any of the values I want. I'm going to check 5 years, 10 years, and 15 years. And you can see that I get the respective amounts. So I'm going to write those down. The amount after 5 years is equal to $2,220.60, I think it was. 40 cents. The amount after 10 years is equal to $32.86.70. And the amount after 15 years is equal to $48.65.10. Yes. So when you type it in, one thing you really got to be careful of is when you raise it to the second power, or the 2x power, make sure you put parentheses around that part. Carissa D, did you have a question? That was your question? And like I said, when you want to check multiple values, it's most helpful to plug it into your table, and that way you can, save on keystrokes on your calculator, so to speak. But, writing the equation, that's probably the most difficult part for this problem. Anything else? Before we flip it over? Question? So if you go second table set, so right now you can see that my table start is set for negative 2.6 something, and then my change in my table, delta table, is 0.43. I'm not even using that right now. What I do is my independent variable, or the X column, I tell it to ask me what I want. And then it will automatically generate the dependent variable. So if you just switch that to ask and auto, then you should be good to go. Okay, any other questions? Once, twice, thrice. Flip it over. Which of the given interest rates and compounding periods would provide for the best investment? 6% compounded semi-annually. How often is semi-annually? Could be twice. 5% quarterly. How often is quarterly? 4 times a year. And what if it's compounded continuously? How many times will it be compounded during the year? That's an infinite number of times. So we actually have 2 different equations that we're using here. If you have an infinite number of times that the interest is compounded, or it's compounded continually, the formula that you use is A of t is equal to P times e to the RT. But if you have other situations where it's not compounded continuously, or it's compounded a finite number of times during the course of the year, then you would use your normal formula, or A of t is equal to P times 1 plus your rate divided by the number of times raised to the nt power. Okay. All right. What do you think? Which is going to give you the better investment? First option, second option, or third option? You pick one. You pick third one. Why? You like the continuous one, don't you? And so that might be. Okay. Obviously, the first one gives you a better interest rate. But you wouldn't really know, would you? And this is the way it goes, you guys. If I take out a 15-year mortgage, okay, do you think that the interest rate is lower or higher than a 30-year mortgage? Any ideas? The interest rate for a 15-year mortgage is lower. And the reason why is you don't have the money as long. And therefore, the bank kind of rewards you by putting a lower interest rate. But if I take out a 30-year mortgage, I end up paying quite, probably a whole percentage point more for my interest. So you got to be able to figure these questions out. And so we're going to see which one gives us the best option. Let's plug it in, okay? The amount at time t, and we don't know what the principal is of our investment, so we'll just put P, but times 1 plus, what's the rate of the first one? 0.06 divided by 2 raised to the 2t power. Let's simplify that. That's going to be the amount at time t is equal to the principal times 1.03 raised to the 2t. Everybody agree with that? Let's write an equation for the second one. Amount at time t is equal to the principal times 1 plus, what's my rate? 0.055 divided by 4 raised to the 4t. Oh, I'm sorry. I'm doing the next problem's 0.055. Thank you for catching that. And then the last one, well, let's simplify this first. I'm going to take 0.05 and divide it by 4. And I get 0.0125. So I have the amount. The amount at time t is equal to the principal times 1.0125 raised to the 4t. And the last one, I'm going to use that other equation. Sometimes people refer to it as PERT. The amount at time t is equal to principal times e to the 0.04t. So I've written 3 equations. Is it clear to you by looking at the equations which one's a better option? Because it isn't clear to me. If you notice, they all have a p and they all have a t, right? So what's going to make the difference is this number. But this number is raised to the 2t power, whereas this one's raised to the 4t power. We have to reconcile this. Let me show you a little trick here, and that will help you out for a problem on your assignment. Don't write this down, but just watch. If you have 1.03 raised to the 2t power, okay, I'm going to suggest to you that that's the same as 1.03 squared to the t power. Do you agree that those are the same? Can you tell me why they're the same? Exponent to an exponent, you will multiply them. So what we can do is we can take that number in the exponent and we can apply it to come up with a better representation. Yep, you sure could. Yep. So let's do that, and then we'll come out with a nice equation. 1.03. Now I'm going to raise that to the second power. 1.0609. So the amount at time t is equal to principal times 1.0609 to the t power. Now I have just the p and the t, and I can focus on that number. If you look at the next one, 1.0125 raised to the 4 power. I get 1.0509. And if we do the last one, we have e, second natural log, to the 0.04. And we get 1.0408. Whoop, times the principal. So you tell me, based off of those formulas, which one looks like it's going to give you the best investment, the first, second, or third? The first. The first has the largest base, so therefore it will result in the best growth. But we weren't able to figure that out until we wrote it in this form. And so that's what you want to do. Okay? All right, number 4. We got 3 left. These go a little bit quicker than that one. A man invests $2,000 in an account that is compounded annually. Annually is how often during the year? Once a year. At an interest rate of 5.5%. What is the amount of the investment after 4 years, and how long does it take it to double? So I'm going to set up my equation. A of t equals principal times 1 plus r over n to the nt. What's the principal? One plus, what's the rate? Divided by, raised to the 1t power. So that means the amount at time t is equal to 2,000 times 1.055 to the t power. So the question is, what is the value of the investment after 4 years? What do I do? Plug in the 4. I take 1.055 to the fourth power, I get that number. I'm going to multiply it by 2,000. I get 2477.65. Now, I know you guys know how to plug in the numbers. The question was, could you write the equation at the beginning? And then once you have the equation, now we get to the more difficult problem. How long does it take for the investment to double? Would you know how to set this up? Question. Raise what? Oh, A of 4. I'm sorry. It doesn't matter. That'll be fine. A of 4 is equal to that. Yep. How long does it take it for the investment to double? How would you set that up? What variable will you be solving for? T. How long you'll be solving for T. So T will be the variable. So if we're waiting for it to double, what's the amount going to be? $4,000. So we put 4,000 in for our amount because we said that the principal doubled to 4,000 times 1.055 raised to the T power. That's the equation we want to solve. Now we want to know at what time makes that possible. How do you solve that equation? Divide by 2,000, we get 2 is equal to 1.055 raised to the T power. How do you solve that equation? Logarithms. We have to get rid of 1.055. We get rid of 1.055 by taking the log of both sides. Log base 1.055 of 2 is equal to log base 1.055 of 1.055 to the T power. What happens on the right-hand side? Cancels. You are left with T. How do we evaluate log base 1.055 of 2? Very good. Log of 2 divided by log of 1.055. And when you do that, you get 12.95. So, again, the importance of logarithms. If you didn't know logarithms, you wouldn't be able to solve that kind of problem. Okay? And that's valuable information. If you want your investment to double, you got to be willing to stick it in there for about 13 years. And are you comfortable with that? If you're not, then you need a higher interest rate. Okay. Now we're going to solve for a different variable. An investment of $800 was compounded quarterly over the course of 6 years. The initial investment resulted in $1,245.83. What is the interest rate of the investment? What are we trying to solve for in this problem? R, interest rate. Can we find R? Well, hopefully we have the other pieces. Okay? What is the amount? 1245.83 equals. What is the principal? 800 times 1 plus. We don't know the rate. How many times was it compounded? 4. Raised to the 4 times 6 years. That gives me an exponent of 24. So we're trying to get at this R. How would you do that? What would you do first? We'll divide off our 800, 1245.83 divided by 800, and I get 1.557. is equal to 1 plus r over 4 to the 24th power. Lots of people struggle when we get here. What do you have to get rid of now? The exponent, you got to get rid of the 24. How do you get rid of the 24? You could bring it to the front if you had a logarithm, but we don't have a logarithm. Taking a logarithm won't help us either. What would you do if this was a squared? You would square root both sides. What would you do if it was a third power? Cube root both sides. So you're gonna find the 24th root. You're gonna take both sides to the 1/24th power. So we need to 24th root both sides. So we're going to take our answer to the parentheses 1 divided by 24 power. That's what gets rid of that 24th power up there. And when we do that, we get 1.0186. Is equal to 1 plus r over 4. Kind of first time for everything, right? First time you read a book, first time you talk, first time you walk. All important steps in your life. Today, first time you ever took the 24th root of something. Oh, Asini's done it before. Many times, I'm assuming? Okay, wow. Right after you learn to talk. Very good. Now we solve by subtracting 1. So you get 0.0186 is equal to r over 4 minus 1. Multiply both sides by 4, and you get 0.0745. If that's r, what's the percent? .45%. Well, these would be the same. I would accept either on the test, which you're not going to have. What's that? Oh, I doubt too many people will be watching. Just the select few. Nobody's gone here today. Oh yes, Grace is gone. Very good. All right. Problem 6, last one. Rabbits. This problem is about rabbits. A for the day. Does anybody know somebody in this building who really, really likes rabbits? Mrs. Wayne. I can never do this problem without thinking of Mrs. Wayne. She loves rabbits. I do too. I love rabbits. They taste like chicken. See, I know. Now you can tell her to watch a video and maybe she'll get upset about that. But I don't know. They do make rabbit stew, don't they? I mean, she can't... You know, awesome pepper, exactly. So, all right. Population of rabbits modeled by this function, P equals 30 divided by 1 plus 5e to the negative 0.3t, where P is in thousands. It's the number of rabbits. T is the number of years since the population is tracked. Find the population after 10 years and find how many years it takes for the population to reach 8,000. So my first question, okay? The problem doesn't ask us to do this, but let's suppose it said, what is the initial population? We covered this yesterday. What do you put in if you want to know the initial population? What is your time at the initial population? Time equals 0. So watch how easy this is to work out. It works out very nicely. And I do this for problems like this, even if it doesn't ask it, because I need to get a frame of reference. I plug in 0 for time. What's negative 0.3 times 0? E to the 0, 1. 5 times 1, 5 plus 1, 6. 30 divided by 6, 5. So was 5 the original population of the rabbits? 5,000. You're measuring in thousands. So 5,000 was the initial population. And rabbits grow. That's what they do, okay? They eat, sleep, and reproduce. That's the life of the rabbit. So good for them. All right. So now what it wants to do is find the population after 10 years. So let's go to work. P of 10. 30 divided by 1 plus 5e to the negative 0.3 times 10. So it doesn't matter how smart the class is, there's always a few people who don't type this correctly into the calculator because it's not something you've generally done before. So let's just make sure our parentheses are in the right spot. You're going to have to put parentheses on the bottom, right? And then you're probably going to need parentheses on your exponent. Because when you type in E, it automatically generates your parentheses. So 30 divided by parentheses, 1 plus 5e to the, what's negative 0.3 times 10? Negative 3. That is our equation. We type it in, and we get 24.02. So the population is 24,020. So P of 10 is equal to 24,020 rabbits. They grew. They had babies. That's what they do. Some of them got eaten by wolves. Sad day. It's the life of a rabbit. But the next question. How many years does it take for the population to reach 8,000? Well, the time it takes for it to reach 8,000, will that be more than 10 years or less than 10 years? Less than 10 years, because in 10 years it got to 24,000. The initial population was how much? 5,000, so it will definitely be more than 0. So let's see what happens here. If you want to find out how many years it takes for population to reach 8,000, what do you plug in for population? 8. If you type in 8,000, you'll actually be working with 8 million because it's measured in thousands. So we just put in 8. 8 is equal to 30 divided by 1 plus 5e negative 0.3t. And we got to solve for that. Oh boy. What do you want to do? Take a shot. Anything you say will be. I'll say correct. Whatever you say. I'll say correct. Correct. Yes. Just stop. Excellent idea. Somebody say another one. What? How? Cross multiply. Let's do it. Over 1. If you got a fraction, turn across multiplication. Okay. 30 times 1. 30 equals 8 times 1 plus 5 e to the negative 0.3t. Now what? Divide by 8. 30 divided by 8. 3.75. 3.75 equals 1 plus 5 e to the negative 0.3t. Now, subtract 1. 2.75 equals 5 e to the negative 0.3t. What do you do now? Divide by 5. 2.75 divided by 5 is 0.55. 0.55 equals e to the negative 0.3t. Oh no, I have to get to the variable. It's in the exponent. Thank goodness for logarithms, specifically natural log. Because things in nature grow continuously. Rabbits breed continuously. So therefore we use the letter E. And we have to use natural log, which is a button on your calculator. So we take the natural log of the answer and we get negative 0.5978. What do you get on the right hand side? Negative 0.3t, because they are inverse operations of one another. Divide by negative 0.3, and you get bada bing, bada bam, bada booski. 1.99 is equal to t, approximately 2 years for the rabbit population to reach a grand total of 8,000. Isn't that beautiful? hold on. Scott raises a really good point. He says, if you come up with a negative population number, you've done something remarkably incorrect. Not necessarily the case, so let me tell you why. Right now is the timber wolf population in Minnesota on the rise or the decline? It's on the rise because we've outlawed people being able to do anything about the timber wolves. So it's kind of sad, actually. There's actually too many timber wolves because you can only have so many for them to be able to feed off the land. So a number of years ago, the population was in decline, and if you came up with a negative number, that would mean that the timber wolf was extinct. Okay, and that's what happens when you see a function go like that. So there are prediction numbers, and if you look at these models, sometimes they start here and then they reach a peak and then they kind of level off because they realize that they can't sustain that capacity. There just might not be enough food. There might not be the right environment. Who knows what? People might get hungry, whatever. 1.99 is equal to t is what you get, though. This is your assignment right there. It's also on the board. There's a decent number of word problems, but this is the last thing you have for the semester. I'm not testing you on this. You have 4 days to do this. Friday night, Saturday, Sunday, Monday, Tuesday, Wednesday, happy days. So, that's that.